here is the theories of how we actually came to be. So there was this thing called a nebula. Basically, it's a giant cloud of dust that is a light year wide. Right? And a light year is how far light can travel in 1 year. So very big. And in these nebulas are the birthplace of both stars and solar systems. There's more than one, right? We just happen to come out of one. So the nebula is there minding its own business. And then it starts to contract. Somehow gravity got out of balance with the outward pressure and started to contract everything in the nebula. This is the fun part. Well, what exactly do you mean somehow? I don't know. They don't know. But they do know something had to disrupt the equilibrium so that this could have happened. Could have been a shockwave from an exploding star nearby. Could have been a collision with another nebula. Could have been Matt Damon flying through it. Not entirely sure what started this, but something started it and it started to contract. So as it contracts, it starts to spin. And this is to conserve angular momentum, lots of physics behind that. But basically, if you think about an ice skater on the Olympics, right, and she starts to spin, and I'm just going to pick she because I need a tutu. So she starts to spin, right, and she gets into like this distortion, and she gets like pencil thin, and you can barely see her, but her tutu is wee, like way out, and looks almost perfectly circular. Right? That's kind of the nebula. Okay, it changes shape from a giant cloud to a flat tutu-like. And again, this is to do with centrifugal force and lots of physics behind that, but basically just think of a tutu. All right, so this flattened disk, or tutu, turns out it will become the plane where the equator of the sun sits. Okay, and the whole thing is about 100 AUs across. Remembering 1 AU is from here to Earth. Sorry, Earth to the sun. And so now this thing is spinning super fast, probably counterclockwise, just throwing that in there. And so this kind of explains why everything is on the same plane and why everything is spinning counterclockwise. It's still got the momentum from the spinning nebula. And again, you can go to that link or not, it's up to you. So remember chapter 3, the better technology, the better discoveries? Well, we have actually seen Beta Pectoris. It is a nebula currently contracting and spinning and forming, starting to form a star. That's what that picture is there. The star's kind of in the middle. Everything is swirling around it. Okay, so this looks like it's in the early stages of spinning. It's about 100 million years old. Yeah, the early stages, right? If only I could say my early stage in life ended at 100 million years old.
This animation shows how the gravitational pull of a suspected planet might warp the inner disk of the Beta Pictoris star system. The dust in the disk feels the gravitational tug of a Jupiter-sized planet, which is orbiting in a slightly different plane from that of the disk. This pulls the dust nearest the inner edge of the disk into a different plane, giving the disk the warped appearance we observe.
So not the most exciting video, but still kind of cool. Alright, so we've got this spinning thing that will eventually become the plane that everything is on, right? And everything's spinning in the counterclockwise direction because that's the way the nebula is going. But what happens to the rest? Right? If you're just spinning around, how are you going to get gas planets and rocky planets? Right, so now we start to see, okay, the condensation theory. And so basically this starts with the dust. Okay. Now the dust in space, I don't know if I've said this before, but it's not your dust bunnies that you would find, hopefully not under your bed, but it's molecules, atoms and molecules. And so what the condensation theory is trying to do is saying, okay, these atoms and molecules are starting to clump together. Okay, so think about atoms and molecules you can't even see because they're too small. They're starting to clump together. And they clump and clump and clump and clump until you get tiny pieces of ice or rock. Very, very, very small. But then they continue to clump and clump and clump and get bigger and so as these dust pieces are clumping together, they're also cooling off. They're radiating away heat in the infrared. So they're trying to cool the nebula down. And it acts as a condensation nucleus. So as you start to clump them together, more things are getting attracted. And as more things are getting attracted to it, it gets bigger and bigger and bigger. It's the same way raindrops form. You have one little piece of sea salt or dust or speck of something in the air, and then water droplets are like, woo, and they attach to it. And then once one does, it's like, hey, party over here, and they all just attract to this little tiny speck of sea salt or dust or whatnot. And so that's what they're trying to say happens in space. You've got one little tiny clump, and some more things start to condense on it or attract to it, and then once a couple things do, it's like, hey, party over here, and so you start to get a bigger and bigger and bigger rock.
Our solar system is the region of space which falls within the gravitational influence of our sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, the gases swept away at the sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, we were left with the gas giants. The The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
Alright, so the video kind of summed up everything. Um, but it did start out with the dust and how it kind of condensed. Okay, so we've got 3 stages in this condensation theory. Before the first stage, we've got the flattened disk that's spinning around. Right? Everything's collapsed, it's spinning, it's flat. The next stage, well, the first 2 stages talk about all the planets, more the inner planets, and then the last stage talks about the gas planets.